In order to understand Newton's second law of motion, we should first know the meaning of the term momentum of a moving body or moving object. This is discussed below. The momentum of a body is defined as the product of its mass and velocity. Thus, momentum equals mass into velocity, or P equals m into v, where P equals momentum, m equals mass of the body, and v equals velocity or speed of the body.
So guys, there is another laws of motion, which is Newton's second law of motion. We have studied Newton's first law of motion. So first law of motion we have studied. First law we have studied. What was it? Object was continue to remain in the state of rest or in motion unless and until it is applied by an external force. This is what we have learned. So there was object A, its velocity was v0. It was supposed to be continued with in a state of rest unless until it is applied by an external force. So if object A, which was at rest, this will continue to remain at rest unless it is applied by an external force. Similarly, object B, it will continue moving with velocity v unless and until it is applied by an external force F. This was what? This was Newton's first law of motion. Law of motion. Now, here we will study about Newton's second law of motion. So, before we proceed for Newton's second law of motion, there is one term called momentum. We have to understand momentum. Momentum is basically for a moving object. So, for example, there is a moving object. We have seen moving object B. It has a mass m, and its velocity is v. So, momentum is defined as P equal to mass of this object m into velocity of this object. So P is defined as mv. So this is called the momentum of the object. What is called? Momentum of the object. It's very important to understand momentum. Momentum is nothing but what? Mass of the object, and the velocity. Now what is mass? Mass we have seen 1 kg, 2 kg, 5 kg, 3 kg. These are called mass, and the velocity is 2 meter per second, 3 meter per second, 5 meter per second. This is called velocity. So what is momentum? Momentum is basically mass into velocity. You just have to get mass and multiply the velocity, you will get the momentum. Now this is also important. SI unit of momentum is basically kilogram meter per second. How? What is unit of mass? Mass is kg. Unit of mass you have learned is kg. And what is unit of velocity? Is meter per second. So what is the unit of momentum? Is kg into mass into kg into meter per second.
Every moving body possesses momentum. Since momentum depends on the mass and velocity of a body, so a body will have a large momentum if its mass is large, or if its velocity, speed, is large, or C, if both its mass and velocity, speed, are large.
Okay, so what we are saying here, we have seen momentum is equal to mass into velocity. Okay, remember this formula. Momentum is equal to mass into velocity. Okay, so we are saying momentum will be large if either mass is large or velocity is large, or both mass and velocity is large. Okay, so this is what the first one is: momentum of an object, okay, B, will be large if either its mass is large or its velocity is large, or both mass and velocity is large. This is what we are saying here. So for the momentum, you have to understand momentum is equal to mass into velocity. Momentum of any stationary object means the object which has velocity 0 will be what? You can guess. Momentum of an object A with velocity v is equal to 0 will be what? P is equal to mass into 0. Now any object which is multiplied by 0 is how much? 0. So an object which is stationary, its momentum will be 0.
Let us solve the sample problem. What is the momentum of a man of mass 75 kilograms when he walks with a velocity of 2 meters per second?
Okay, so here we have to solve a very simple problem. We have to find a momentum of a man of a mass 75 kg. So there is a man, okay, okay, its mass is 75 kg. Okay, when walks with a velocity, this man is walking, okay, with a velocity of 2 meter per second. It's very simple. What is momentum? We have learned the formula: momentum is equal to mass into velocity. Okay, and mass of the man is how much? 75 kg. Okay, and its velocity is 2 meter per second. So what is the momentum? Very simple: mass into velocity. So 75 into how much? 2. 75 into 2 is how much, guys? Is 150. And what is the unit? Kg meter per second. So this is very simple example just to understand. Okay, when a man is walking with 2 meter per second, what is the momentum? You have to first see the formula. You have to visualize the formula. What is formula? P is equal to mass into velocity. And then you have to find or think of the value of mass and value of velocity. Value of mass is given 75, value of velocity is given 2. It's so straightforward. And then you put into this, and then you will get 150 kg meter per second as its momentum.
According to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. The rate change of momentum of a body can be obtained by dividing the change in momentum by time taken for change. So, Newton's second law of motion can be expressed as force proportional to change in momentum divided by time taken.
Okay, so guys, now we move to Newton's second law of motion. This is the statement of Newton's second law of motion. Okay, this you have to remember. So what is the Newton's second law of motion? The rate of change of momentum of a body is directly proportional to the applied force. So rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force is applied. So this is what? This is basically Newton's second law of motion. Now I will explain you. So first let's put into this into the mathematical formula. Okay, so what we are saying, the rate of change of momentum. So rate of change of momentum is what? Rate of change of momentum, rate of change of momentum. Okay, is what? It's a change in momentum divided by time taken. This is called rate of change of momentum. What is rate of change of momentum? Change in momentum divided by time taken. And this is proportional to the force applied. This is what Newton's second law of motion. So if there is a object B on which a force is applied, and then there is a change in momentum, okay, of this object. So this change in momentum is proportional to this applied force, and it's in the direction of applied force. So this change is in which direction? Direction of applied force. This is what Newton's second law of motion. So what we are saying? Again, force applied is proportional to change in momentum divided by time taken. Okay, so again let me explain you again. This object B, okay, initial momentum was P1, okay, and it was moving very nicely here. Then suddenly there was a force applied on this body, okay. There was a force applied F. What happened? If you apply the force on this body object B, its momentum changed to P2. Okay. Now what was the momentum? P1. P1 was mass into velocity 1. What is P2? P2 is now mass into velocity 2. What is P? P you remember? P we said P is mass into velocity. It's a momentum. So it has the momentum P1. Then there was a push. There was some guy who pushed him. So then his momentum changed. So now what Newton's second law of motion is? The change of momentum. Initially it was P1, now it's P2. This change is how much? P2 minus P1. This change in momentum divided by time t, this is called rate, is proportional to the force applied. Now this equation you can rewrite as F proportional to P2 minus P1 by time t. Now this is Newton's second law of motion. So I hope you understood the Newton's second law of motion. What is Newton's second law of motion? The change in momentum by time taken is proportional to the force applied. Now what is change in momentum? Initial momentum was something, then you apply the force, it changed momentum to P2. So now P2 minus P1 is a change in momentum which is proportional to the force applied.
Mathematical formulation of second law of motion. Consider a body of mass m having an initial velocity u. The initial momentum of this body will be m u. Suppose a force F acts on this body for time t and causes the final velocity to become v. The final momentum of this body will be mv. Now, the change in momentum of this body is mv minus m u, and the time taken for this change is t. So, according to Newton's second law of motion, force proportional to change in momentum by time taken, force proportional to mv minus m u by t.
Okay, so we just have seen, the force is proportional to a change in momentum by time is a Newton's second law of motion. So we'll try to derive, the formula for the force and change in momentum. Now, this object B, had the initial velocity u and then a force applied, okay, and then it's become final velocity v. Mass of the object is m. So what we are saying, force is proportional to change in momentum. Now what is the final momentum? Mass into velocity, because momentum is what? Momentum is what? Mass into velocity. Now when it move to this position after applied force F, what is velocity v? So what will is momentum? Mass into velocity. So this is final momentum. Now what is initial momentum, guys? Initial momentum is initial velocity u, is mass is m, so it's mass m into u. And say suppose this F was applied on this for time t, so divided by time t. Now here you see mv minus mu divided by t. Here mv minus mu. M is common in both, so you take this common out. Now this is v minus u by t. Now you remember, guys, acceleration. What was acceleration formula? Acceleration. Okay, what was this? This was change in velocity by time taken. Remember? So change in velocity by time taken is acceleration. So if the body has initial velocity u and is changed to velocity v in time t, the acceleration of object b is basically v minus u by t. Okay, so the b, once the object b moves from u to v, its acceleration is v minus u by t. Now in this equation you replace v minus u by t by a, because what is a? A is acceleration. Acceleration is what? Change in velocity by time taken, and change in velocity is how much? V minus u by t of this object b. So if you replace this and put it here in this equation, in place of v minus u by t you put a, and then this equation become force is proportional to mass into acceleration. Thus the force acting on body is directly proportional to the product of mass of the body and acceleration a. The product in the body by action of the force, and it is act in the direction of acceleration. So now, guys, what you have seen, this expression of Newton's second law of motion is expressed in terms of acceleration and force. Earlier what was in terms of? Pf was proportional to change in momentum, okay, by time. This was in terms of momentum. Now it's in terms of acceleration. Okay, so force is proportional to mass into acceleration is now Newton's second law of motion in terms of acceleration.
This is another definition of Newton's second law of motion. The relation F proportional to m times a can be turned into an equation by putting in a constant k.
Okay, so we just have seen that force can be proportional to mass into acceleration is Newton's second law of motion. Okay, now you take this out proportional and put the exact equation. Okay, in proportional you cannot solve any problem, right? So you have to put into the equation terms. Now you will learn more about proportionality in the next classes, but for the basic, you can replace this proportionality with the constant value k. So force equal to k into mass into acceleration. Now this is the equation where left side is force, and right side is k into mass into acceleration. Now you don't know the value of k, right? Now in SI unit, if everything is in SI unit, okay. Now what do you mean by SI unit? Force should be in Newton, okay, mass in kg, and acceleration is meter per second square. This is called SI unit. So now in SI unit the value of k is 1. Okay, so if you put the value of k is equal to 1, what will happen? This equation become F is equal to mass into acceleration. Okay guys, now remember this is Newton's second law of motion. Okay, what is Newton's second law of motion? Force is equal to mass into acceleration. And what is direction of acceleration? Acceleration direction is direction of the force. Remember, scalar and vector quantity, force and acceleration both are vector quantity. And how this is related? Okay, acceleration and mass is and force is related with the Newton's second law of motion, and this is force is equal to mass into acceleration.
Newton's second law. The net force on a body is equal to the product of the body's mass and its acceleration. In equation form, or force equals mass times acceleration.
So this is just a recap of Newton's second law of motion again. Guys, why I am telling this again and again, so that it goes in in your brain and stays there. Newton's second law of motion. Okay, Newton's second law of motion is force is equal to, okay, this is wrong, there should be direction. Force is equal to mass into acceleration. Okay, this is Newton's second law of motion. Now in terms of momentum, this is force is equal to change in momentum, okay, divided by time. Remember this. Most of the time you will use this formula, but sometime, when the change of momentum you have to calculate, or force you have to calculate when change in momentum and time is given, then you use this formula. So this is called Newton's second law of motion.
Sample problem 1. What force would be needed to produce an acceleration of 4 meter per second square in a ball of mass 6 kilograms? Solution. The force needed is to be calculated by using the relation force equals mass into acceleration. Here, force F to be calculated, mass m equals 6 kilograms, and acceleration a equals 4 meter per second square.
Okay, so this is a simple problem to understand what we have learned, Newton's second law of motion. So what is Newton's second law of motion? Force is equal to mass into acceleration. Now how you will solve this equation problem? Okay, first you have to understand what is to be calculated and what is given, and then you remember the formula, and then you put the value into this and get the unknown value. Okay, what force means, then you have to calculate the force. Force is equal to what? You have to concentrate on the questions, and you have to read it as many times as required to understand the questions. So first, what force should be needed? So what is the question? What force? So force is equal to what? Now you know what is to be calculated. Now there are givens. So need to be produce an acceleration of how much is acceleration? 4 meter per second square. So acceleration is how much? 4 meter per second square of a mass 6 kg. So mass is given, acceleration is given. Guys, we have to find out the force. Is it not easy? I hope it's easy. Okay, for you guys. Newton's second law of motion is what? Force is equal to mass into acceleration. Now mass is how much? Mass is given 6 kg. Okay, and how much is acceleration? 4. So how much will be the force? Anyone? Force will be 24. And what is the SI unit? Newton. Okay guys, understood? Very easy problem. You understand what is required, then you try to see what is given, and then you put into formula and you get the value. Don't forget to put the units. It's very important.
Sample problem 2. What is the acceleration produced by a force of 12 newtons exerted on an object of mass 3 kilograms? Solution. Here, force F equals 12N, mass M equals 3 kilograms, and acceleration, to be calculated.
Again, this is very easy, problem to be solved. So what is the acceleration? So acceleration is equal to what? Means it has to be calculated. Okay. So you have to calculate acceleration. Now what is given? Force. Force is given how much? 12 Newton. Okay, so first you have to put it like this. So what is given and what you have to calculate. So force is 12 Newton. And how much is the mass? Mass is 3 kg. Okay, so force is 12 Newton, mass is 2 kg, 3 kg. Then what is the acceleration? It's very easy. Now you remember the formula of Newton's second law. Force is equal to mass into acceleration. Okay, force is how much? 12 Newton. And how much is the mass? 3 kg. What is the acceleration? So this is the equation. Now it's very easy. 12 is to 3 into a. So 3a is equal to 12. So a is equal to 12 by 3 is equal to 4. And what is the unit? 4 meter per second square. This is very important questions. Okay. So this I will put as important. Okay. For medical or engineering. Okay. So listen this carefully. Calculate the force required to impart to a car a velocity of 30 meter per second in 10 seconds starting from the rest. The mass of the car is 1500 kilometer. So there is a car. Okay. There is a car. Right. Now this car, try to understand first the problem. Okay. Then the solution will be very easy for you to understand. The car, calculate the force. So first of all, what you have to calculate? The force. Okay. So you have to see force is equal to what? Okay. Now what is given? Mass is given. Very good. So what is given? Mass is given. So you know mass of the car. Okay. Is how much? 1500 kg. Now you know the formula. Okay. What was the formula? F is equal to mass into acceleration. Wait. Okay. Mass into acceleration. So now force, if you want to calculate the force, mass is given. What you need? Acceleration. Now here you see acceleration is not directly given. So you have to calculate the acceleration. Now you have to remember the formula for acceleration. Okay. When velocities are given. So V is equal to U plus AT was the equation of motion. Okay. The first equation of motion. So here you see the initial velocity of this car. Okay. How much it was? 0, because it's starting from rest. Starting from rest means initial velocity is 0 because it was on the rest standing car and then you started driving. Then what you did to this car? Okay, you applied accelerator. Okay, what you applied? You applied the accelerator and this car start moving. With what velocity? 30 meter per second. Okay, in how much time? This was the force that you applied was for 10 seconds. So for 10 seconds you applied, accelerator, and then car moved to 30 meter per second from starting. So put in this equation. V is how much? 30. Initial velocity is how much? Starting from rest, 0. Time is how much? 10 seconds. So acceleration is 3 meter per second. Now you know the mass, you know the acceleration. So is it easy to calculate force? Can you? Okay. So you know thought how to calculate. So how much is acceleration? 3 meter per second square. How much was the mass? 1500 kg. So guys, now I think you can very easily calculate the force. Applied the mass and acceleration. So force is 4500 newtons.